Solvents usage in pharmaceutical industry. The objective of this presentation is to understand why pharma industry uses such a high quantity of solvents and be aware of the solvent's impact on the greenness of an API synthesis. Solvents are ubiquitous in the pharma industry. This scheme represents a basic chemistry process. It is important to remind that all processes are run under a nitrogen atmosphere in order to avoid explosive solvent-oxygen mixtures. The process begins with a wash of all the equipment train with a reaction solvent. The starting materials, which are generally solid, are charged into the vessel. Then the reaction solvent is charged under stirring. The reagent is dosed in solution at constant temperature. An in-process control is made to check the completion of the reaction. The excess reagent is quenched, generally with an aqueous solution. The extractions are carried out using additional solvent and the aqueous phase is discarded. The organic phase is transferred into the second reactor. The initial vessel is rinsed. The solution is concentrated and a non-solvent is dosed by distillation at constant volume in order to crystallize the product. The slurry is transferred to the filter dryer. The second vessel is rinsed. The product is dried in vacuum under slow stirring and eventually discharged into drums. Finally, all the equipment train is cleaned with the appropriate solvent. Solvents are used for reactions. Because most of intermediates are solid, in order to ensure an efficient mass transfer, to offer a safety barrier by limiting the consequences of exothermic reactions. The ideal dilution in a process is 5 to 10 volume, that is to say 5 to 10 liters of solvent per kilogram of starting material. Solvents are used for extraction because intermediates and APIs are scarcely soluble in water. No- Non-solvents are used to crystallize the product in order to maximize both yield and purity and in order to get the desired polymorph. And, last but not least, solvents are used to clean the equipment and this is the main source of solvent consumption. Why is water seldom used as a solvent? Because most intermediates are poorly soluble in water. Water is a reactive solvent, incompatible with many reagents. The pollution of water is not easy. But water can still be used in phase transfer catalysis processes. And what about supercritical carbon dioxide? Because it is often a non-solvent with a polarity similar to this of hydrocarbons. But supercritical carbon dioxide has other many useful applications, such as extraction of caffeine from coffee. In order to illustrate the solvent usage in pharma industry, here are the most used solvents in Sanofi plants. The top 6 were in 2012 toluene, methanol, ethanol, isopropanol, acetone, and dichloromethane. Most of them are recycled. Solvents have a main impact on the process greenness. Whatever the metrics considered, global warming potential, cumulated energy demand, process mass intensity, carbon dioxide impact, life cycle assessment, the yield has of course a direct impact. But solvents are the most often the main contributors. The process mass intensity of a synthesis is the amount of material needed to prepare 1 kilogram of product. In the pharma industry, it is often higher than 100. Solvents represent more than one half of this material, and water circa one third. Reagents and reactants represent only 7%. And in this analysis, cleaning solvents were not considered. How do process chemists and engineers improve the process greenness? First of all, by limiting the amount of solvents, by designing concentrated processes, using phase transfer catalysis when possible, and, in the plants, cleaning the equipment with water and detergent. By recycling the solvent by distillation, which is very frequent in industrial workshops. This is easy when solvents form a heteroazeotrope, such as toluene and dichloromethane with water, but not easy with homoazeotropes such as ethanol and water. This is also difficult to separate solvents with close boiling point. In order to facilitate the recycling, it is important to avoid complex mixture of solvents. If not recycled, the solvents are burned to produce steam. A special attention is also given to the process water. Unnecessary washing and extractions are avoided. In conclusion, one can hardly produce APIs without solvents, but one can often reduce their amount. In your synthesis, try to reduce the number of solvents, ideally not more than 2 per step. Do not forget also to reduce the amount of water. And, from a qualitative aspect, select the most desirable solvents by using the solvent selection guides.